Now in this question, you are given with x of t and you are asked to plot four waveforms. First one is x of t into u of 1 minus t. Second one is x of t into u of t minus u of t minus 1. Third one is x of t into delta of t minus 3 by 2. And fourth one is x of t into u of t minus 1. When x of t is given, we already know it. We need to plot what is u of t 1 minus t. So from the basics it says that you have to do the shifting operation first, then you take the reflection. So I need to do t plus 1 first, then you take the reflection. Or I can write this as u of minus t plus 1. So it is t plus 1 first, then reflection. So same is being done here. I have drawn u of t, which extends from 0 to infinity with an amplitude of 1. Then I need to do u of t plus 1, then I will take the reflection. So it is t plus 1 means shift left by 1. Then I will take the reflection and I will be ending up getting u of 1 minus t, which extends from minus infinity to plus 1. So if I take the reflection of this waveform which extends from minus 1 to infinity, the reflection of it will be present from minus infinity to plus 1. Now what we have here is the multiplication of x of t and this waveform. So this waveform extends from minus infinity to 1 with an amplitude of 1, and this signal is present between minus 1 to 2. So if you multiply any signal with an amplitude of 1, you will get back the same signal. But here the constraint is between what range of values of t you are multiplying x of t and the other function. So this extends from minus infinity to 1, whereas this waveform is present between minus 1 to 2. So what is the overlapping space which gives you the perfect waveform? That is minus 1 to 1. So whatever is the waveform between minus 1 to 1, that will be reproduced here when you multiply x of t by u of 1 minus t. Now for the second case, I need to plot u of t minus u of t minus 1. Now u of t, I have it here. What is u of t minus 1? U of t minus 1 is, see, u of t plus 1 was shift left by 1. U of t minus 1 is shift right by 1 with the amount with an amplitude of 1. Now if I subtract u of t minus u of t minus 1, I mean u of t minus 1 is subtracted from u of t, I will get a waveform which extends from 0 to 1 with an amplitude of 1. This is u of t minus u of t minus 1, because u of t extends from 0 to infinity, u of t minus 1 extends from 1 to infinity, and if you subtract you get 1 minus 0, that is the waveform present here. But for all the values of for all other values of t, the amplitude here is 1, here also it is 1, so 1 minus 1 will be 0. So you will get a square waveform, a square wave starting from 0 till 1 with an amplitude of 1. Now if I multiply, what you have here is x of t, this waveform multiplied by this. So if I multiply, what do I get is, I am multiplying a waveform of amplitude of 1 which extends between 0 to 1. So what is a waveform which is present between 0 to 1? That is this waveform. So that will be replicated here as the product, whereas to the left of u of t minus 1 we have 0, here also we have 0. So any waveform multiplied by 0 will be 0. So for the second, this was for the first waveform. For the second waveform, it is this is the waveform which I'll be getting, that is which extends from 0 to 1, because you are multiplying u of t minus 1 with an amplitude of 1. So any waveform multiplied by amplitude of 1 is same waveform, so which extends from 0 to 1 because of this. Now third one is, you are multiplying x of t with delta of t minus 3 by 2. Now what is delta of t minus 3 by 2? Delta of t is an unit impulse function which is having its value only at t is equal to 0. So this is your delta of t with an amplitude of 1. Now delta of t minus 3 by 2 is, it is shift right by 3 by 2. Now 3 by 2 is valid on a continuous scale, so 3 by 2 is 1 by 1.5. So amplitude here will be 1, and this will be delta of t minus 3 by 2. Now if you multiply this waveform with this, what do I get is, where is 1.5 here? In between 1 and 2, so 1.5. At 1.5, what is amplitude? 2. So rest all the values of t, delta of t minus 3 by 2, amplitude is 0. So 0 multiplied by any waveform will give you 0, but except at 3 by 2. 3 by 2, the amplitude is 1. So whatever is amplitude at 3 by 2, that will be reproduced here. So for the third case, the waveform what I get is, at this is 3 by 2, the amplitude will be 2. Now the fourth case is u of t minus 1. Now what is u of t minus 1? We already know it is shift right of u of t by 1. So that is, it will be shifted like this. So it will extend from 1 to infinity. Now if you multiply any waveform with an amplitude of 1 with x of t, your original waveform, you will get back the original waveform. So but the product depends upon the existence of u of t between the limits of t. So what is the limit of t here? U of t minus 1 extends from 1 to infinity. So whatever is a waveform from 1 to infinity, I will be getting it here. So for the fourth case, the waveform what I'll be getting is this with an amplitude of 2. Why? Because it extends from 1 to 2, and thereafter I don't have any waveform. The amplitude is 0. 0 multiplied by 1 will be 0. And before that also you have waveform, but here u of t minus 1 amplitude to the left of t is equal to 1 is 0. So you will get this waveform. So this is for the first case. This waveform is for the first case. This is for the second. This is for the third, and this is for the fourth case. So in this problem, you are given with x1 of t and x2 of t, whereas x1 of t is this waveform, this is triangular waveform which extends from -1 to 1, and this is a rectangular waveform x2 of t which exists from -2 to 2. Now I have redrawn it here, x1 of t and x2 of t according to some specific scale. Now you are asked to find x1 of t plus x2 of t, x1 of t by 2, x1 of t into x2 of t, then x2 of 2t, then the subtraction of x1 of t from x2 of t. Now for the first case, it is x1 of t plus x2 of t. Now the addition of these two signals will result in a waveform. See, if I take a interval -1 here, 0 and 1 here, there is no waveform present of x1 of t between the limits -2 to -1. So here it will be 0, and here the amplitude between -2 to -1 is 1. So when you add from -2 to -1, it will be 1. Amplitude is 1. This amplitude is 1. Similar is the case to the positive side, that is from 1 to 2. You have no waveform here, and you have one waveform here with an amplitude of 1. So it will be from positive 1 to 2, the amplitude is 1. Now thereafter, from -1 to 0, okay, let me take the value of the function at 0. At 0, here the amplitude is 1, here the amplitude is 1. So 1 plus 1 is 2. So from -1, it will finally jump to 2 at t is equal to 0. Similar is the case on the right hand side, because it is a even signal, that is the signal and its reflection is same. So this is the waveform what we get if you add these two signals, that is x1 of t and x2 of t. So we can cross verify as well. See, at if I take -0.9 and -0.9 here, the amplitude here is at -0.9, the amplitude is 1. Here the amplitude is 0.1. So 1 plus 0.1 is 1.1. Then at minus 0.8 it is 1 plus 0.2, that is 1.2, 1.3, and finally it reaches at 0, it is 1 plus 1, so the amplitude here is 2. So you get this waveform when you add these two signals. Now the second one is x1 of t by 2. From the basics, it's pretty clear that when you have a scaling factor in the denominator, your time axis or the waveform gets expanded. So, and the expansion factor is 2. That means this waveform will get expanded, which is present between minus 1 to 1 will be present between minus 2 to 1. So x1 of t by 2 is the waveform which will be present between minus 2 to 2, but there will not be change in the amplitude will be 1. That means my scale 1 got multiplied by 2, so you get expanded version of the original signal, that is x1 of t. Now third one is, this is the second case. Third case is you are multiplying these two. Now when you are multiplying any waveform, be it x1 of t or any waveform for that matter, if you are multiplying any waveform with an amplitude of 1, you get back the same waveform. Now existence of product depends upon the overlapping area between these two waveforms. Now where is this waveform present? This is present between minus 2 to 2, and this is present between minus 1 to 1. So there is no waveform which is present for x1 of t from minus 2 to minus 1. So it will be 0 multiplied by 1, it will be 0. Similar is the case from 1 to 2. Here you have no waveform, here you have 1. So 0 into 1 is 0. So you get the same triangular waveform which exists between minus 1 to 1 with an amplitude of 1 when you multiply x1 of t into x2 of t. Right? Now this is the third waveform. Now fourth waveform is x2 of 2t. Now when you have a scaling that is present in the numerator, my waveform gets compressed, contrary to the previous case wherein you had x1 of t by 2, our waveform got expanded. Here x2 of 2t with a compression factor of 2, so my waveform will get compressed. The original waveform which is present between minus 2 to 2 will now be present between minus 1 to 1 with an amplitude of same, that is 1. Now here you have to make a note that while doing the expansion or the compression, the amplitude of the waveform will never get changed. Only there will be a expansion in the time scale or the compression in the time scale. Now next one is x2 of t minus x1 of t. Now if you subtract x1 of t from x2 of t, see from minus 2 to 1 you have the amplitude of 1, whereas here you have 0. So 1 minus 0 is 1. So between minus 2 to 1 it is 1 minus 0, so amplitude is 1. Similar is the case to the right, it is 1 minus 0, again it will be 1. Now for the next case, here at t is equal to 0 you have 1 minus 1, that means you will get a 0 at t is equal to 0. That means this waveform will tend to 0 like this, and even the waveform on the right side will tend to 0 like this. So you can cross verify by taking a point here, say minus 0.9. What is minus 0.9? What is our amplitude here? 1. Here you have 0.1. So 1 minus 0.1 is 0.9. Then you have 1 minus 0.2, 0.8, 1 minus 0.3, 0.7. Finally it will be 1 minus 1. So it is 0. So you will get a waveform which looks like this for the fifth. This is for the fourth case and this is for the fifth case. Now in this problem you are given with x of n which is specified for different intervals of n. and you are asked to plot y of n, which is equal to 3 times the function x of n by 2 plus 1. Now first of all, in order to do manipulation on x of n, we need to know what is x of n. So from the basics we already know that if you are asked to do x of n by 2 plus 1, first shifting has to be done. That is, I need to do n plus 1, then I need to scale it by a factor 2. That means I'll get the expanded version of my waveform. But there is a factor, new factor here, 3, and this has to do only with the amplitude of the samples of x of n. So every sample of x of n will get multiplied by the amplitude 3. Now let us start plotting x of n. Now x of n, it is given that the range of n extends from -7 till 6. See, if it is given as the limit which is n between -8 and -3, that means n is greater than -8 and less than -3, that means my n value is between the range -7 to -2. Okay, so I can plot my x of n to be extending between -7, so I'll divide this equally, -3, -4, -5, -6 and -7, because it is n is greater than -8, and since it is a discrete scale, greater than n greater than -8, the next value has to be -7, and here you have n less than 7, so the previous value has to be 6. 3, 4, 5 and 6. Now for this interval of n, that is n between n greater than -8 and less than -3, that is between -7 and -4, the equation of the x of n is minus of n plus 8. So at -7, put the value of n to be -7. So you get -7 plus 8, that is 1, and you have a minus sign here. So at -7 I'll have an amplitude of -1. Next, at -6, if I substitute n is equal to -6 here, -6 plus 8, that is 2, and you have minus sign, so it will be -2 here. And similarly at if I put the value of n to be -5, it will be -5 plus 8, so it is 3, and you have a minus sign, so it will be -3. At -4 plus 8, it is plus 4, and you have a minus sign, so it will be -4. So this is the waveform of x of n, which is present between the values of n, that is -7 to -4. Now at n is equal to -3, the value is specified, it is 6. So I can directly draw the waveform at n is equal to -3. Now for other values between n greater than -3 and less than 0, so greater than -3 means it is for -2, and less than 0 means for -1. So for values of n of -2 and -1, the value of x of n is -6. So I can directly plot it here, -6 here and -6 again here. Now the next value of x of n is given to be n for the range of values of n between -1 to 7. So n greater than -1 means it is 0, and n less than 7 means it is 6. So for this set of values of n, x of n is n. So at n is equal to 0, x of n is 0 because it is n. So you have a 0 here. At 1 you have 1, at 2 you have 2, at 3 you have 3, at 4 you have 4, at 5 you have amplitude of 5, at 6 you have amplitude of 6. Why? Because for this value of n ranging between 0 to 6, the value of x of n is n. So this is my x of n. Now what I need to do here is I need to shift this waveform by 1. Now whether it is towards the left or right depends upon the sign here. So it is n plus 1. So I need to shift this waveform completely left by 1. Now if I were to redraw it, this is x of n plus 1, and I'll draw it in a smaller scale. 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, and you have minus 8 because my waveform is getting shifted left by 1. Now whatever is a waveform at 6 will come at 5, and whatever is a waveform at minus 7 will go to minus 8. So minus 8 amplitude is minus 1, then minus 2, then minus 3, then at minus 5 it is minus 4, at my minus 4 you have 6. This is not according to the scale I am drawing, just for your understanding. It is at minus 4 you have 6, at minus 3 you have minus 6, at minus 2 you have minus 6 again, at minus 1 you will have 0 because whatever is a sample at 0 that will come here, and at 1 it will be 1, then 2, 3, 4, 5, and at 5 you will get 6. Now what you need to do here is, next is you need to expand this by a factor 2. So scaling is done, the scaling factor is present in the denominator, so my waveform will get expanded by the factor 2. So whatever are the samples at particular values of n will get multiplied. That means n value will get multiplied. That means the sample at 0 will remain at 0 because 0 into 2 is 0. The sample at 1 will go to 2, sample at 2 will go to 4, 3 will go to 6, 4 will go to 8, and 5 will go to 10. Similarly on the left hand side, the sample at minus 8 will go to minus 16. Sample at minus 7 will go to minus 14, sample at minus 6 will go to minus 12, sample at minus 5, and so on. So then you have a factor that is 3. So this 3 helps in amplifying the sample values. So these sample values, all the sample values, minus 1 will be multiplied by 3, that is you will get minus 3, minus 2 will be multiplied by 3, minus 6, minus 3 will be multiplied by 3, that you get minus 9. So all the sample values, the amplitudes will get multiplied by 3, and my waveform will get expanded by the factor 2. So the final waveform x of n by 2 plus 1, that is 3 times, will look like this. Now the waveform, the sample at minus 8 will go to minus 16. So if I write minus 16, minus 14, minus 12, minus 10, minus 8, minus 6, minus 4, minus 2, and 0, 2, 4, 6, 8, 10, and 12, and so on. So the sample at minus 8 will be moved to minus 16, and that amplitude will be multiplied by 3. So at minus 16 the amplitude will be minus 3. At minus 14 the amplitude will be minus 6. At minus 12 the amplitude will be minus 9. Again it is not up to the scale. At minus 10 the amplitude, this is 5, so it will get expanded to minus 10, and the amplitude gets multiplied by 3. So 4 into 3 is 12, so minus 12. At minus 4, that is it will go to minus 8. 6 into 3 is 18, so this is 18. Then rest 2 will be multiplied by 3, so you get minus 18 here, minus 18 here. Then at -1, the sample will go to -2. So what you have here is 0. So -2 will have 0. At 0, the amplitude is 1. So that will get multiplied by 3. So you get 3. At 1, you have the amplitude of 2. So it will be 6. Then 9. Then 12. Then 15. And finally 6 into 3 is 18. The positive side is almost up to a scale, but negative side I have not drawn up to the scale, but I have given you the values. That is -3, -6, -9, -12, 18, -18, -18, 0, 3, 6, 9, 12, 15 and 18.